On the previous video, we talked about what it means for pressure to be equalized, for my pressure to remain constant. And we said that, for example, in my bigger box had a higher temperature, so my arrows were moving faster, more number of force collisions, so on and so forth. And so because of that, the temperature was hot to start, and then it decreased, it got cold. And because of that, have a non-rigid system, and so my non-rigid system shrunk, it got smaller. And because of that, that's what allowed the pressure to remain equalized. And what we mean by equal pressure is that the pressure outside is equal to the pressure inside. Now, in this case, I showed 3 collisions and 3 collisions, but that's not always going to be the case. And so another example of what up above is like our balloons. Our balloons, when we have a higher number of particles, so I'm going to change what it is that we're changing now. Now we're going to have an open system. Oops. So now we're going to have an open system. And with my open system, at first I have less particles in there. So this is what we did the other day, where they're at room temperature, so they're all going to be moving the same. But in this one, I only had 3 particles. And again, the particles on the outside are going to push against it. And that's why it stops moving, because the number of particles on the inside pushing are the same number of pushes on the outside. So my pressure outside equals my pressure inside. And so as this balloon gets bigger, as I put more and more particles in it, the balloon has to get bigger, so that way the number of collisions stays the same as what's happening outside. And so I've got that, and now there's more collisions. I'm going to add a couple more here, because since we're taking up more space, there's more of that air surrounding it. Because I have more particles in here. All right, and so where they're showing is I have particle collisions here. This one's kind of off kilter, but we can see where it's hitting. And I have particle collisions here. And so my particle collisions are equalized. The amount that are happening outside are equal to the amount that are happening inside. This is true, we'll come back to that picture in the next video. This is true when we talk about our vacuum. Excuse me. So when we talk about our vacuum, we had a lot of particles inside contacting the inside of the trash bag. Because the trash bag was spread out, there was more air particles smashing it on the outside. And so in this case, I have 1, 2, 3, 4, 6, 7, 8. I have 8 particle collisions, 8 particles on the inside, and I have 8 particle collisions, I guess I should put PC, on the outside. And for consistency's sake, I'm going to put the outside first. And so because of this, particle collisions. So because of this, this is equal. So it's equalized. Well, now when I took the vacuum, what the vacuum does is it removes the particles from the system. And by removing the particles from the system, other particles rush to be in that space. And so now, because my trash bag is so much smaller, I have less collisions inside than I did outside at the start. And so it pushes my bag in towards me. And so now what I notice is I have, don't add one more. Yeah, let's add one more. And so now I have 4 particle collisions inside and 4 particle collisions with the outside. Okay, so let me show you these. So I have 1, 2, 3, 4 collisions. So this time I have 4 particle collisions outside and 4 particle collisions inside. And so that means my collisions are equal. The amount of collisions outside the system are equal to inside the system. And that's why the bag shrunk, is it shrunk until they were equal on the outside and the inside. To the point that since you removed all of the air, or most of the air particles, now it was your body that was hitting against it. And so this is what we mean by an equalization in pressure. When pressure is said to be equal, it's because the pressure inside and outside are equal. So for this one, this would have been that we increased the number of particles, temperature stayed the same, my volume increased, and so now pressure stays the same. And that's the exact opposite of what happened here. So my PVTN chart, my number decreased, my temperature remained the same, the volume decreased, so that pressure inside and outside the system could remain constant.